Good day, everyone. This is Tamil Assistant Professor working in Department of EEE at KIT Kalangar Karnanidhi Institute of Technology, Coimbatore. Today, I am going to deal with the topic of fundamental of speed governing mechanism. Before going the topic, we need to know about the how to control the real power and related definition. Let's start with introduction to real power frequency control and definition. Real or active power control is one of the important control action to be performed during normal operation of the system to match the system generation with the continuously changed load. In order to maintain the system frequency to a tolerable limit of plus or minus 5%, a change in system causes a change in the speed of turbine generator system, leading the change in system frequency. The change in speed of all turbine generator is controlled by two category. One is primary control and second one is secondary control. The primary control, the speed change from synchronous speed initiates the governor control action, resulting in all the participating generator turbine unit taking up the change in load and stabilize the system frequency. And secondary control, it is adjust the load reference set point of selected turbine generator unit so as to give the nominal value of frequency based on the formula synchronous speed capital N is equal to 120 F by P. Is the N is directly proportional to the frequency, where N is equal to speed in RPM, F is equal to frequency in Hertz, P is equal to number of poles. So the frequency of the system can be varied by varying the speed of turbine. Frequency is closely related to the real power balancing of overall network. Under normal operating condition, the system generator run synchronously and generate power which is drawn by all the load and real power losses. Definitions. First of all, we need speed governor. It comprises of the element which are directly response to the speed and whose position influence the action of other element of speed governing system. The speed control mechanism, it include all the equipment like relay, pilot valve, servo motor, pressure, lever, and linkage mechanism. It is between the speed governor and the governor control valve. The governor control valve, it includes those valves that control the input to the turbine and that are normally actuated by the speed governor with the help of speed control mechanism. The speed changer or speed motor, it is a device by means of which the speed governance system may be adjusted to change the speed or power output of the turbine in operation. The speed governing system, this includes the speed governor mechanism, speed control valve, and speed changer. Now, the basics for speed governing mechanism. The real power in power system is being controlled by the driving torque of the individual turbine of the system. The speed governor is main primary tool for the load frequency control, whether the machine is used alone to feed a smaller system or it is part of the most elaborated arrangement. The speed governing system of the steam turbine by controlling the position of control valve or gate. The following figure shows arrangement of speed governing system is used to steam turbine to control the output of the generator to maintain constant frequency. The components of speed governing system are as follows: speed governor, hydraulic amplifier, linkage mechanism, and speed changer. First one, flyball governor. It is purely mechanical speed sensitive device coupled directly to the hydraulic amplifier which adjusts the control valve opening via the linkage mechanism. As load increases, the speed of the turbine decreases and the speed changer gives rise command to the flyball, move outwards at the point B, move downwards, and the reverse happens with the increase the speed. Hydraulic amplifier. It consists of pilot valve and main piston. With this arrangement, the a lower power pilot valve movement is controlled into high power level movement of the oil servo motor piston. Linkage mechanism. It is a rigid link pivoted at point B with the combination of ABC, and CD is another rigid link pivoted at point D. The function of the link mechanism is to control the steam valve or gate. We get the feedback from the movement of the steam valve via link CD. Speed changer. It is made possible to restore the frequency to the initial value after the operation of the speed governor, which has steady state characteristics. A small downward movement of the linkage point A corresponds to increase the del PC in the reference power setting. This is the whole model of turbine speed governor system. This is the flyball governor, speed changer, the hydraulic amplifier, A, B, C, and CD is a linkage mechanism, and this is one the steam valve opening and close to the turbine. So working principle of turbine speed governor system: as load increases, the speed turbine decreases. Listen, the load increases, the speed of the turbine is decreases. So the speed changer, the speed changer gives rise command to the flyball. The speed changer gives rise command to the flyball. It moves outward. Flyballs move outwards and point B moves downwards. If point B downwards and D moves upward, at point B downward, the point D is moving upward. If point D moving upward, the high pressure oil enter into the upper pilot valve, and press the main piston downwards and open the valve and gate to increase the flow of steam to the turbine. Increase the flow of steam to the turbine. Thereby, speed of the turbine increases and maintains constant frequency. If load increases, the speed turbine decreases. The speed changer gives rise command and flywheel moves outward and point B downwards and D moves upward and high pressure oil enter into the pilot valve and press the main piston downward and open the valve or gate to increase the flow of steam to the turbine. Thereby, speed of the turbine increases and maintain the constant speed. For case 2, a load decrease, the speed of the turbine increases. Listen, as load decrease, the speed of the turbine increases. The speed changer gives lower command and flyballs move toward inside and the point B moves upward and D moves downwards. If D moves downwards, the low pressure oil enter into the lower pilot valve and press the main piston upward and close the gate or valve. It reduces the flow of steam to the turbine, thereby speed of the turbine decreases and maintains constant frequency. This is the operation of turbine speed governing mechanism. Thank you.